everyone, thank you so much for coming to this lesson. So we're going to be covering graphs and how to sketch them. So like always, there's going to be timestamps. So feel free to skip to any parts you want to. In this lesson, the learning objectives we're going to be covering is to be able to understand and sketch graphs of functions, to be able to interpret the solution of equations graphically, and to be able to use proportional relationships and their graphs. So we've already gone through how to sketch quadratic graphs in a previous video. So if you don't remember how to do that, then please go back to that. But now we're going to be learning how to sketch cubic graphs. So cubic graphs always have quite a similar shape. So they always go, if the coefficient, so a cubic equation firstly is anything which has an x cubed in it. So it could be x cubed plus 2x squared plus x plus 7, for example. And for any cubic equation, the graph would look kind of alike. So if the coefficient in front of the x cubed is positive, so if it's positive, then the graph would always go from the bottom left of the axis to the top left. So if we have a axis like that, if the coefficient in front of the x cubed is positive, then it would always be something like this. If, on the other hand, so this is for if it's positive. If, on the other hand, the coefficient in front of the x cubed is negative, the graph will go from the top left to the bottom right of the graph. So it would go something like this, like something like that. So this is if you have something with a minus x cubed in front of it. So that was just talking through what the shape of the cubic graph would look like. But then once you know what the shape would be, you can actually start to sketch it out. And the main things you need to know to sketch is where the graph would cross the different axes. So for a cubic graph, it really depends on where the roots are. So for this, they've already given you the cubic graph in a factorized form. So the graph would cross the x-axis at x equals 0, x equals 1, and x equals minus a half. So then you can just draw this on the diagram. So you'd have this, you'd have 1 here, and you'd have minus a half. Then it would cross the y-axis. So if we were to expand the equation, it would be x, and then you'd have, if we expand this bit first, you'd have 2x squared plus x minus 2x. That's just minus x minus 1. So then if we expand this further, that's just 2x cubed minus x squared minus x. And if we were to plug in x equals 0, you'd see that if we have the equation as y equals something, if we were to plug in x equals 0, then you would just get y equals 0. So the graph should cross the x-axis at 0. And you can tell that through the fact that one of the ways that it would cross the x-axis is at 0. So it crosses both y and x at 0. So you know that the graph will go from the bottom left to the top right because it's positive x cubed. So the graph would look just something like this. And then to find what these points are, well, curves, these are called stationary points, and that would be covered in a later video. So you would do that through differentiation. So now if we move on to the second graph, which is x minus 3 all squared times x plus 1. So similarly, the two places where it would cross the x-axis would be where y, so if it was y equals, be when y equals 0. So this would be at when x equals 3 and when x equals minus 1. Now, because it's x minus 3 squared, x equals 3 would appear twice. So this is what's called a repeated root. And if there's a repeated root, then this means that instead of going through these points once, you'll kind of just like sit on the point, if that makes sense, because it's a repeated root. So if we draw out the graph, we'd have -1 here and -3 here. Again, if we expanded this, we would see that it's just x cubed. It's positive because there's nothing in front of one of the x's. So it's still going to go from the bottom left to the top right. So then the graph would just look something like this. So because this is a repeated root, it won't go through because that means it has to come up again and go across another point, but that can't happen because there's only 2 roots. So it kind of just sits on x equals 3. And then where it crosses the y-axis, you can solve that by plugging in by plugging in y equals 0. So we can try that. So let's expand it. So if we expand the first one, we would get x squared minus 6x plus 9, and then you'd have x plus 1, and then if we expanded this further, you'd get x cubed plus x squared minus 6x squared minus 6x plus 9x plus 9, so it'd cross the y-axis. So if you plug in x equals 0, it would cross the y-axis at y equals 9. So that's just a run through of how you can sketch cubic graphs. So now let's try an example. So we have an example here, y equals 2x plus 1, x minus 2 squared. So if you try this question yourself, so pause the video and try it out, and then we can go through it again. So to draw this, we need to figure out where it's crossed the x-axis and where it crossed the y-axis. So across the x-axis when y equals 0. So if y equals 0, this would be, so you'd have it like this. So this would be when x equals minus a half, or when x equals 2. And again, we have a repeated root here. So when we draw the graph, we'd have x equals 2 here and minus a half. Those are the 2 points where to cross. So let's just write x and y. And then we want to also find out where it crossed the y-axis. So that would be when x equals 0. So if we expand the whole expression out, we'll get 2x plus 1, and then you'd get x squared minus 4x plus 4. Then if we expand this more out further, you get 2x cubed minus 8x squared plus 8x plus x squared minus 4x plus 4. So then you know that if you plugged in x equals 0, y would just be 4, so it'd cross out 4. And then you know because it's positive x cubed, it will go from the bottom left to the top right corner. So the graph would, and there's a repeated root on 2, so the graph would look something like this. So moving on to sketching a Quartic graph, this is the highest power graph you would need to sketch. So they would normally give this to you in the form that is already factorized. You don't really need to worry about factorizing it. But similarly to like if you're drawing a cubic or quadratic, you just need to find out where it would cross the y-axis and where it would cross the x-axis. So for this question, you need to find out where it crosses the x-axis first. So this would be when y equals 0. That would be at when x equals 0, x equals minus 1, and x equals 2. So because this is x minus 2 squared, this will be a repeated root. And Quartic graphs can either look something like this, or would have something like this, or some kind of version of that. But it always starts from really positive, and then it should end as positive as well. And that is if the x power 4 is positive. If it's got a negative sign in front of it, it would start off as being going from the negative going from the bottom all the way upwards, and it would end go in the negative end but upwards. So this way you have x is 0 is one of the roots, x is minus 1 is another, and x is 2. So it's positive, so you want to start from the positive side. So it would just look something like, and it will be a repeated root there, and it would go up like that. So because this is a repeated root, it's like with a cubic, it kind of just sits on that root. So yeah, that's basically all there really is to sketching a Quartic graph. So again, you need to figure out where it's across the y-axis. For this one, you know x equals 0 is one of the roots. So then immediately y equals 0 is also another one. So yeah. I have a practice question here, so feel free to pause and try it out for yourself. So you have fx is equal to 1 minus x and x plus 4 to the power 3, and you want to try and draw the graph. So we know that this will be Quartic, as you'll have x to the power 3 here, but then you also times x, so you would have x to the power 4. But because this is negative x, you'd have negative x to the power 4. So the graph will start from the bottom and end somewhere at the bottom as well. Now we want to try and find out where it crosses the x-axis. This would be at when x equals 1 and when x equals minus 4, where this x equals minus 4 would be the repeated root. And now when we want to find out where it crosses the y-axis, this would be the constant is if you expanded this whole thing, what the constant would be at the end. So it'll take really long to expand that, so you don't have to do that. We can just think about what the constant would be. So you definitely have this power, and that would be raised to the power 3, so you'd have 4 to the power 3. You'd also have times by 1, so that would just be 64. So then we can plot the points where it crosses the axes. So you'd have 1 here, you would have minus 4 here, you'd have 64 here. So the graph would look something like, it would be like this, and then it would go like that, and it would come back down like that. So I'm going to go through some other like graphs that you could have. So in general, if you have a graph that has n, which is even and positive, the graph is always going to look, it would always look something like either like this or something like this. So that would always be the case. So whenever you have something which is like y equals x to the power 6 or y equals minus x to the power 6, if it's plus 6, it will be this way, and then if it's negative 6, it will be the other way. And otherwise, if you another version you could have is if n is odd and positive. So this is talking about in general case like a x to the power of n. If n is positive and odd, you'd always have something that would go from one corner of the graph to the other, so something like this. So that's like if it was y to x minus 3, and then if it was negative, like y equals minus x to the power of 3, it would just go the other way, something like this. That makes sense. So another version, if n is even but negative, so let's say you had y is equal to x to the power of minus 2, and then if you remember indices, that should equal to y equals 1 over x to the power of 2. Then you'd have two graphs that look like this, and like vice versa, if this is negative, like minus 1 over x squared, it would just be on the opposite, it would just be flipped around. But that's how they would all look. So this could be the same for like when it's y equals 1 over x4 or y equals 1 over x6. That would always look like this. And then the final version of graphs you'd have if n is odd but negative. So like then the graph would always be in one quadrant, and then in the opposite like that. So this is if it is like y equals x to the power of minus 3, which is also the same as y equals x to the power of 3. So that's the same if it was negative, this negative, it will just be in the other quadrant. It will just be flipped around. But these four are just the main graphs that you would face. So this is, we've all gone through. You just need to know to power 4 really. So I've gone through all of them that you need to know. But these are quite important as well. So whenever you have something is 1 over x squared or x4, x6, it's always going to be in the top 2 quadrants. So if that's negative, then it will be the negative 2. And if it's odd negative, such as y equals 1 over x to the power of 3, then it would always be in the top right and the bottom left. And if it's negative 1 over x to the power of 3, it will just be in the other two. So just memorize these 4 graphs. So if we now move on to interpreting solutions of equations graphically. So this now goes, if you remember what we were working on when we did simultaneous equations, as let's say you had a quadratic as a linear equation and you wanted to try to find the two solutions to that. That would, and the way you could graph that is, so let's say you had a quadratic equation that looked something like this, and then you'd have a linear equation, and let's say you had two solutions, then the linear equation would go through like that, which the fact that there's two intersections between the quadratic and the linear shows that there's two solutions. Similarly, if you had a quadratic equation like this, but then the line only touches the graph once, then that means that there will be only one solution to the equation. And then similarly, if there's a quadratic graph like this and the line goes like this, then that means there are no solutions to the equation because the lines don't intersect in any way. So yeah, so if you ever have like a question that's asking you to interpret the solutions of your simultaneous equations graphically, that's all you have to do. So yeah, the number of solutions indicates the number of times that the linear equation crosses and the quadratic equation crosses, and how many points that they intersect at. So for example, let's say you have these two equations, y equals x squared minus 4x plus 5 and y equals 2x minus 4, and you want to try and interpret these solutions graphically. What you do is you just equate the two together as they're both equal to y. Then you'll get 2x minus 4 equal to x squared minus 4x plus 5. And then you would just rearrange this to get it equal to 0. So you would get 0 equals x squared, and then if you subtract 2x from both sides, you'd get minus 6x. And if you add 4 to both sides, you get plus 1. Then if you factorize this, and then you can see if you can factorize it, and you would get x minus 3 and x minus 3. So then the only solution is x equals 3. And the next thing you want to do is you want to try and draw the two graphs. So for the first one, you know it will cross at 5, and then you can either complete the square to see where the minimum point is, and if you can try factorize it, but if you try that, you can try this yourself, but you would find that there are no factors. So one way to see whether it crosses the x-axis, you could either complete the square, or you could either use a discriminant. So go back to the videos, and if you don't remember how to do that, try it out. But what you should get is, if you try the discriminant, then you should find out that there are no real solutions. Discriminant would be less than 0. And if you do complete the square, then you would find a minimum value that has a positive y value. So that means it also lies above. So then the graph would look something like this. And then you have y equals 2x minus 4. So you know that will cross at minus 4. And you can figure out where it crosses the x-axis. If you do 0 equals 2x minus 4, 4 equals 2x, so x equals 2, have x only cross once when x equals 3. So the graph would look something like this, but more straight. But yeah, remember to use a ruler. And then you can figure out the full intersection of what the y value is by plugging x equals 3 back into the equation. So you would get y equals 2 and then 3 minus 4, which is just 2. So the solution to this equation is just this here, which is 0.3 2. So yeah, if it asks you to interpret a solution of, so they give you two equations, like simultaneous equations like this, where it's both y equals something and y equals something, then whatever solution you get, how many solutions you get indicates how many times your linear graph should cross the quadratic graph, and then you can just draw the two and show it using that. So the last bit you need to know is you need to be able to use proportional relationships on their graph. So so there's two types of proportion. There's direct proportion and there's indirect proportion. So to write out direct proportion, so if you have two statements like saying y is directly proportional to y, you just write y is directly proportional to x. And this is equivalent to saying that y is equal to kx, with k being the constant of proportionality. And so if you were to draw the graph, proportionality. So if you were to draw the graph against, so x is here and y is there, as you know, it's just y equals kx, with k being the gradient of the graph. The graph would just look like something like this. It would just be a straight line going through 0, and the gradient will be depending on what k is. So that's just an overview of direct proportionality. So it could be like y could be the circumference of a circle, and x would be the area, so be the circumference of circles directly proportional to the area of the circle, for example. And another, so then you can also have inverse proportion. Okay, so this is, you could say y is indirectly proportional. If y is indirectly proportional to x, then that would mean y is proportional to 1 over x. And that's equivalent to saying y is equal to k over x. So therefore the graph of an inverse proportion would be if x is on this side and y would be on this side. It would just be, the graph would just look something like this. Yeah, so if you remember the graph of, so we're just doing it for the positive values of x. So if you remember the graph which was like odd and positive, like something like y equals ax to the power of 1, so let's say it's kx to the power of 1. So that would just, you would just have it in the top right quadrant and in the bottom left quadrant. So we're just doing for positive values, so it would just be in this quadrant. So that is just in a nutshell what proportionality is and what their graphs are. So if we do some example questions, this would make it more clearer. So we have an example here. Y is directly proportional to x when y is 24, x equals 8. So we have to work out the value of y when x is equal to 2. So if y is directly proportional to x, that means y is directly proportional to x, and that means that y is equal to kx. So what we need to do is we need to find out what the value of k is. So we can do that by subbing into the numbers that they've given us. So it'll be 24 is equal to k times 8. So if you do 24 divided by 8, that just means 3 is equal to k. So then the graph would look like, if you have y on this, sorry, if you have x on this and y here, it will just be something like this, which y is equal to 3x. And then we want to work out the value of y when x is 2. we just say that y is equal to 3 times x. We just sub in k is 3, and that's just equal to 6. Now if we do an exam question based on direct proportionality, so pause the video and try the questions for yourself and then come back to the solution. So the question is, the amount of money earned by Sasha is directly proportional to the number of hours she works, H. If she works for 9.5 hours, she earns £155.80. Express M in terms of H. So we just say, as M is directly proportional to H, we say M is equal to KH. And then she works for 9.5 hours, so we can say H is 9.5. And then she earns £150.80. The M is 155.8 equal to K. H, so then you just do 150.8 divided by 9.5. So then you should get K is equal to 16.4. So then M is just equal to 16.4 H. So then we want to use the equation or otherwise to find out how many hours it would take her to earn £680.80. So you just plug in M as 680.8 equal to 16.4 H, and then we just do 688.8 divided by 16.4, and that should give H is equal to 42. And then if we were to draw the graph of M against H, you'd get H here, M here, be another straight line with M is equal to 16.4 H. So now moving on to an example of inverse proportionality. So it's saying that y is inversely proportional to x. So that means y is equal to k over x using the definitions we learnt previously. So now it's saying when y is equal to 2, x is equal to 3. Then we want to find out what k is. So we just sub in y is 2. That's equal to k over 3. That means k is just equal to 6. Then we want to work out the value of y when x is 18. Then y is just equal to 6 over 3, which is just 2. So then if you were to draw the graph of x against y, it would just be something like this, with y being 6 over x. Okay, so now we have an inverse proportion exam style question. So you can pause the video here and try it for yourself, and then we can go through it together. So it's saying the time taken, T, for customers to receive their orders at a fast food restaurant is inversely proportional to the square of the number of staff S on duty. So we first want to write that out. So saying T is inversely proportional to S squared. So it's equal to K over S squared. And it takes 20 minutes for customer orders to be taken when there are 4 staff members on duty. So we want to write an equation for T in terms of S. So we can just plug these numbers in. So T is equal to 20, and then that's equal to K over S is equal to 4, so 4 squared. Then if we do 20 times 16, we would get 322 is equal to K. So then it's saying if the number of staff is doubled, how many times quicker will the customers receive their orders? So we want to find out the time when S is double, so when S is equal to 8. So we can plug the values in, so we get T is equal to 322 over 8, so that's just equal to time is equal to 40. Sorry, not 8, it's 8 squared. Then you do 320 divided by 64, so that's just equal to 5. So the time would be 5. So yeah, what I just did there it would be quite a common mistake for loads of students. They would just forget that you want to square it. So just remember what the equation looks like, and just remember to read the question properly. But yeah, that's the answer. So the key to answering inverse and direct proportionality questions is just to make sure you read the information clearly and just write down everything as you go along, and just fill in the numbers and just remember the formulas. The direct proportionality is y equals kx. For inverse is y equals k over x. So just remember that. Yeah, that's everything. So thank you so much for listening to this lesson. I really hope it was useful. So just to sum up what we did, we learned how to sketch graphs of functions up to the power of 4, and we learned how to interpret solution of the equations graphically. So go back to what we were learning about simultaneous equations and try if you can plot those equations using a graph of using what we just learned. And also we learned how to use proportional relationships and their graphs. Thank you.